Hey guys, and welcome to this next lesson talking about a few more properties of exponents. So the main property that we're going to discuss now is what happens when you take a base and you raise it to an exponent, and then you take that whole thing and raise that to an exponent. What happens? Well, let's check it out. First, starting with a bunch of friendly, nice, positive exponents. So here's my question. What does it mean to raise something, and I use the word thing very intentionally here, to the second power? I think it means take that thing and multiply it by itself twice. So I think we can write this as m to the fourth multiplied by, well, itself, m to the fourth. And from our previous lesson on properties of exponents, I hope we know that we'll have m times n times n times n times m times n times n times m, 8 m's being multiplied by one another, m to the 8th power. All right, so we end up with m to the 8th power. Very nice, very nice. All we did is just use the definition of what an exponent means. All right, let's do some more with positive exponents. So now let's take that same thing. This kind of serves as our base now. We kind of have a base within a base. We're taking m to the fourth, and we are now going to multiply that by itself 1, 2, 3 times, right? Because we're taking this thing, if you will, and multiplying it by itself 3 times, raising it to the 3rd power for a grand total of m to the 12th. All right, so I hope this is becoming familiar. I hope you can see why this is happening. Perhaps you're noticing some patterns as well, but always want to know what's going on behind the scenes. Last example with positive exponents. What if we had 3 to the 2nd power, and we raised that then to the 5th? So 3 to the 2nd times 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 3 to the 2nd. We're going to have a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 threes being multiplied by one another. 3 to the 10th power. Perhaps you knew that already. Just laying the foundation for what's coming up. All right, awesome. So when we have positive exponents, we've got no problem taking a base, raising it to a power, and then taking that whole thing and raising it to another power. Well, what happens if we have negative exponents? Well, here's my claim. Whenever I have any negative exponents, kind of the first thing I do is rewrite things so that I've got all positive exponents. With positive exponents, it's much easier for me to visualize. So I'm going to take 2 to the negative 3rd power, and I'm going to write that as 1 over 2 to the 3rd. That's all I've done is rewrite this interior of the parentheses, and of course this is all still being raised to the 2nd power. All right, all positive exponents, very groovy. What does it mean to take something and raise it to the 2nd power? It means take that thing, that base, whatever it is, and multiply it by itself 2 times for a grand total of, I hope you already know this, 1 over 2 to the 6th power. For what it's worth, this is also known as 2 to the negative 6th power in case you were trying to make some predictions about what was coming up. But of course, if you have to choose between giving your reader an expression with positive exponents or one with negative exponents, yeah, give them one with positive exponents. So this is definitely a preferable answer in this case. All right, making moves. Okay, once again, we've got a base being raised to a power, all being raised to another power. One of them is positive, one of them is negative. This is a little trickier, perhaps. Well, what does it mean to take a thing, a base, and raise it to the negative 3rd power? I think what that means is take the reciprocal of that base, I'm just going to leave it as a box for now, and raise it to the positive 3rd power. So the question is, what is the reciprocal of 4 to the 3rd? Well, I think the reciprocal is going to be 1 over 4 to the 3rd. And we know what to do from here. Everything is groovy. We have some base. We're raising it to the 3rd power. That means take that base and multiply it by itself 1 time, 2 times, 3 times, for a grand total of 1 over 4 to the 9th power. Awesome, awesome, awesome. Now, what happens if both our, interior and exterior exponents are negative, for lack of a better word? Well, same idea as before. What I'm going to do is I'm going to start within the parentheses. I'm going to rewrite this expression using only positive exponents. So we've got 1 over 7 to the 2nd, and I'm not even dealing with this outer exponent for now, one thing at a time. Okay, so now we have all positive exponents within our parentheses. Let's see if we can have all positive exponents everywhere. So what does it mean to take something and raise it to the negative 2nd power? Well, I think it means take the reciprocal of this base and raise it to the positive 2nd power. Well, what is the reciprocal of 1 over 7 to the 2nd? Oh, just 7 to the 2nd over 1, or just 7 to the 2nd. All right, and now this is kind of like one of our original nice and easy problems that we did to begin this lesson. I think if I take something and I raise it to the 2nd power, it means 7 squared times 7 squared for a grand total of 7 to the 4th power. All right, so now we know how to deal with these kind of examples, whether we have positive exponents, negative exponents, or some combination thereof. So let's take a look at a few more, slightly more complicated examples. All right, in this case, well, the strategy we use is exactly the same, right? We just have something a little bit more complicated going on within our parentheses. Note to self, there is no indication of what operation this is, but that's really multiplication there. That's 2 times b to the third power, all of that. Again, coincidentally to the third power. But right now, this is kind of like 2 to the first, no exponent here. Well, what does it mean to raise a base to the third power? Well, it means multiply by itself 3 times. So we've got 2 times b to the third, and well, we're going to multiply that by itself 1, 2, 3 times. Well, that's all I did is I just took this 2 times b to the third and multiplied by itself 1, 2, 3 times. And what do we end up with? Well, I think we've got, let's see, 2 times 2 times 2, so 2 to the third multiplied by b to the third times b to the third times b to the third, b to the ninth. So I think our grand sum in this case is 2 to the third times b to the ninth. I do want to make a note that when we're dealing with constants, like actual numbers like 2 and 7 and 5, if you have something like, I don't know, 5 to the 7th power, don't spend your time multiplying 5 by itself 7 times to actually tell me what it is, you know, like 35,000 or something. But 2 to the third, yeah, that's 8. I think that's pretty easy to do quickly in our heads. And I think that 8 times b to the ninth is actually just a little bit easier for our reader to digest than this. And so, you know, we're always thinking, hey, what is the best product we can give our reader? In this case, if it's something easy to evaluate, go ahead and evaluate it. All right, let's do a few more. Same idea here, we just got a little bit more going on within the parentheses. I would like to first take what's in these parentheses and write it without any negative exponents. That's the strategy I like to take. So we've got x to the third multiplied by 1 over y to the fourth. I'm going to put this x to the third over 1, just so we've got a fraction being multiplied by a fraction. Of course, this is all still being raised to the second power. I'm going to go ahead and kind of clean this up a little bit. Just multiply these two fractions together. We get x to the third over y to the fourth. And then we are going to take this fraction, raise it to the second power. I'm feeling good, no problem at all. We're going to end up with x to the sixth power over y to the eighth power. And I hope that you know why. Okay, more examples. All right, now we've got lots of things going on, negative exponents galore. Let's do it. All right, first things first, let's rewrite what's inside the parentheses using only positive exponents. So, okay, I'm not even dealing at all, not even dealing with this at all right now, just ignoring it until we've really cleaned up what's inside the parentheses. So let's say we've got m squared over h to the third. Now we can take that and raise it to the negative third power. I'm feeling good about this. Instead of raising something to the negative third power, we are instead going to raise the reciprocal of this base to the positive third power. So h to the third over m squared. All of that to the third power. I hope you know what this is going to end up being, but in this case, I'll go ahead and write it out for us. Multiplied by itself once. Ooh. Multiplied by itself once, twice, 3 times for a grand total of h to the ninth over m to the sixth power. And I'm hoping that, we're definitely finding some patterns here that's going to allow us to do these quickly and accurately, but always want to make sure we know exactly what's going on behind the scenes with regard to positive and negative exponents and what they actually mean and our fraction skills. All right, so I hope you're feeling really good about this. I'm feeling pretty good about this. And so what I'd like us to do is take a moment. I've got 6 quick practice problems, and I'd love for you to pause the video and try them on your own and see how they went. All right, so our first one, all we're doing is taking x squared and multiplying it by itself 4 times. We're going to end up with x to the 8th power. Awesome. In example number 2, we're going to rewrite what's inside the parentheses as 1 over y squared. All of that raised to the 5th power. We're going to end up with 1 over y to the 10th. Okay, in our third example, we've got negative exponents galore. Let's first rewrite what's in our parentheses as 1 over a to the third, still being raised to the negative 2nd power. But, of course, no one likes evaluating anything raised to a negative exponent, so let's raise something else to a positive exponent, namely the reciprocal of this, namely a to the third. A to the third power raised to the second will yield us a to the 6th power. All right, making good progress. In this case, it's just important, do not neglect this constant, 4 in this case. Sometimes students hyperfocus on just the variables and kind of lose sight of these constants. Really important. So I'm even going to write this one out, right? We're raising this base to the third power, so we've got 4 times x squared. I'm even going to put in this little times there because I think it really helps me understand what's going on. Multiplied by 4 times x squared, multiplied by 4 times x squared. So I think we've got, let's see, 4 times 4 times 4. I could write 4 to the third, but I think it's easier to just write 64. And we've got x squared times x squared times x squared, which is x to the 6th. So our grand product in this case is going to be 64 times x to the 6th power. All right, two more. Same as always, when I have any negative exponents, let's go ahead and rewrite these using positive exponents. So 5 times 1 over y to the 4th, all of that to the 2nd. I'm going to take this 5 and I'm going to write it as 5 over 1, which allows me to clean up what's inside these parentheses as 5 over y to the 4th, all of that to the 2nd, multiplying by itself, so we end up with 25 over y to the 8th. And last but not least, holy cow, negative exponents, all sorts of stuff. All right, first things first, let's take care of what's inside the parentheses and this negative exponent. I'm going to make the ink a little smaller. So we've got, in our numerator, we've got 3 over 1 times 1 over x squared, right? I just rewrote x to the negative 2nd as 1 over x squared. All over y to the 4th, I'm going to put that over 1 because I know I'm going to have a lot of fraction stuff going on here. All of that to the negative 3rd power. If you want, you can also just kind of take this and take it off to the side on your page and do the dirty work and then come back and deal with this negative 3rd power. All right, so this inside the parentheses, the numerator, I'm just going to clean this up, actually multiply these together, so we'll have a numerator of 3 over x squared. So we've got 3 over x squared over y to the 4th over 1, still all to the negative 3rd power. And to be quite frank, I would probably take all this and do it on the side anyway. But since I started keeping this negative 3rd around, I'm going to be consistent and keep it there. So within this parentheses, I'm actually, you know what, I'm going to go ahead and do this off on the side. We know that this is actually a fraction division problem, so we can actually rewrite it as fraction multiplication. So that's 3 over x squared times the reciprocal 1 over y to the 4th. So that is 3 over x squared times y to the 4th. This is all still being raised, holy cow, to the negative 3rd power. All right, we know what it means to raise something to the negative 3rd power. It means take the reciprocal of that base, so switching the numerator and denominator, raising it to the 3rd power. I hope we feel comfortable taking care of this. We're going to have, this whole base being multiplied by itself 1, 2, 3 times. So 1 time, let's make it a little smaller. 1 time, 2 times, 3 times, and you are always welcome to write it out. So we have x to the 6th, y to the 12th over 27 is our final expression in this case. So, woo! Listen, all we were just really handling here is one new property of exponents and working in a review of the other ones we learned previously. I hope you found this helpful, and I hope you enjoyed.